The concept of diet personalization is entering an exciting new era, one in which the gut microbiome may serve as a central biomarker for predicting how different foods affect metabolic health, digestion, and overall wellness. Traditional dietary guidelines focus on generalized recommendations, but mounting research suggests that individuals respond differently to the same foods due to variations in gut microbial composition, diversity, and metabolic function. The idea that a simple stool sample could reveal the unique profile of one's gut ecosystem and guide precisely tailored dietary choices is no longer purely theoretical. Emerging studies indicate that analyzing the microbiome could predict blood sugar responses, lipid metabolism, inflammatory signaling, and even satiety responses to specific foods, opening the door to truly personalized nutrition strategies. The microbiome acts as a dynamic mediator between food intake and physiological outcomes. SCFA-producing bacteria, such as Faecalibacterium prosnitziae, Roseburia, and Bifidobacterium, respond differently to dietary substrates depending on their abundance and activity in each individual. For instance, one person's microbiome may efficiently ferment legumes into butyrate and propionate, yielding improved insulin sensitivity and reduced inflammation, while another's microbiome may produce lower SCFA levels from the same meal, leading to less pronounced metabolic benefits. This variability helps explain why standardized diets sometimes produce inconsistent results across individuals and emphasizes the value of microbial profiling as a predictive tool. In this context, foods like pistachios may be especially potent for personalized dietary strategies. Pistachios combine fermentable fibers, polyphenol, protein, and healthy fats into a single food matrix, which feeds a variety of beneficial microbes and encourages SCFA production. In microbiome-based dietary trials, pistachios have been associated with increased abundance of SCFA-producing taxa, improvements in gut microbial diversity, and reductions in pro-inflammatory metabolites. For individuals whose stool analysis reveals low levels of Roseburia or Faecalibacterium, regular pistachio consumption could provide targeted substrates to help restore microbial balance and enhance butyrate production, supporting gut barrier integrity, glucose regulation, and systemic anti-inflammatory signaling. Conversely, individuals already rich in SCFA-producing bacteria might experience complementary metabolic benefits, such as improved satiety, moderated blood glucose excursions, and enhanced lipid metabolism. Personalized nutrition informed by gut microbiome profiling could also help optimize the timing and combination of foods. For example, sequencing data might reveal that certain microbial populations are most active during the evening, suggesting that consuming fiber and polyphenol-rich snacks like pistachios before bed could maximize SCFA production overnight, enhance fasting glucose stability, and strengthen gut barrier function. Likewise, morning intake of high-fiber legumes or polyphenol-rich fruits could be timed to align with microbial peaks in fermentative activity, ensuring that the host receives the maximum metabolic benefit from each meal. Over time, this approach could create a dynamic, 24-hour nutrient strategy tailored to an individual's microbial rhythms, metabolic responses, and health goals. Moreover, microbiome-guided personalization extends beyond metabolic outcomes. Analysis of stool samples can identify individuals whose microbial composition may predispose them to systemic inflammation, poor lipid handling, or gastrointestinal sensitivity. For these individuals, foods like pistachios, which provide anti-inflammatory polyphenol, MUFAs, PUFAs, and fermentable fibers, can be prioritized to modulate microbial metabolism, enhance SCFA production, and reduce inflammatory signaling. In effect, the microbiome becomes both a diagnostic tool and a guide for dietary intervention, allowing clinicians, nutritionists, and individuals themselves to make evidence-informed choices that go beyond calories or macronutrient ratios. The potential of microbiome-based personalized nutrition is further amplified when integrated with longitudinal tracking. Sequencing a stool sample at baseline, implementing targeted dietary changes such as pistachio supplementation, and monitoring microbial and metabolic shifts over weeks or months could allow individuals to iteratively refine their diet for maximum benefit. Machine learning algorithms may one day predict the optimal combination of foods, timing, and portion sizes for each person, based on their unique microbial and metabolic profile. This would transform nutrition from a generalized recommendation into a precision science, where gut microbes serve as both sensors and effectors of health. Even more exciting is the prospect of combining personalized microbiome insights with other omics data, such as metabolomics and proteomics, to create a holistic view of how diet influences systemic physiology. For example, metabolites produced by gut microbes in response to pistachios might interact with liver, muscle, or adipose tissue metabolism in ways that could be measured, tracked, and optimized. This integrative approach could allow nutrition to be fully individualized, turning foods into precision tools for enhancing metabolic health, reducing inflammation, and preventing chronic disease. In summary, the stool sample of the future could serve as a roadmap for personalized nutrition, revealing which foods best support each individual's gut microbiome and metabolic resilience. Pistachios, with their unique combination of fiber, polyphenol, protein, and healthy fats, may play a particularly valuable role in this paradigm, providing targeted substrates that enrich beneficial bacteria, enhance SCFA production, and improve metabolic outcomes. By leveraging gut microbiome data, it may soon be possible to design diets that are not only nutrient-dense but precisely aligned with an individual's microbial ecosystem, optimizing gut, metabolic, and systemic health in ways that were previously unimaginable. The era of truly personalized, microbe-informed nutrition is on the horizon, with plant-based whole foods like pistachios at the forefront of this transformative approach.